All right, for this lesson, excuse me, you will learn about lipids, proteins, and nucleic acids. This is the work for November 9th. It's a Thursday when I'm out for my conference at Penn State. Before you begin this lesson or these lessons, you need to take the carbohydrate review quiz on Canvas. To access that quiz, it's under Canvas, Quizzes, Carbohydrate Warm Up. Just to let you know, you may use your notes on that quiz, so take it seriously. It will count for points, and you cannot take it again. Okay, so let's talk about lipids. You guys already know some things about lipids. You know that lipids are fats. Lipids actually also include oils and waxes as well. Waxes are like a candle wax. If you think about if you put water on a candle, it actually repels water, it will fall off. That's why we know it's a lipid. Oils like olive oil or canola oil or vegetable oil or sunflower seed oil, those are all lipids as well. Lipids, as you know, contain the elements carbon, hydrogen, and oxygen. And yes, I know there is a missing space. Just add carbon, hydrogen, and oxygen to your sheet. Okay, so the fact that lipids contain carbon, hydrogen, and oxygen, and actually they contain more carbon and hydrogen than oxygen, makes them what we call hydrophobic or water-fearing. You can think about oil when you put it in water. When you put oil in water, it repels that water. It's because it's hydrophobic. There are three major functions of lipids. The first is long-term energy storage. So your body can actually store a lot of excess energy as lipids. You know this because if you continue eating 50 bags of potato chips every single day, eventually all that excess energy, the excess potato chips, are going to be stored on your body as fats. When your body needs to break down more energy and it runs out of carbohydrates, your body will go to fats next. So that's why people do like aerobic exercises. Aerobic exercises are going to cause you to run out of carbohydrates eventually, and cardio exercises, and then your body is going to go to fats to burn them. Another important function of lipids is that they're part of cell membranes. The molecule that is a lipid that's responsible for cell membranes is known as a phospholipid. A phospholipid. And I'm actually going to draw that on here for you. Phospholipid is spelled P. I'm not very good at drawing with this, sorry. H-O-S-P-H-O-L-I-P-I-D. Phospholipid. Phospholipids are part of cell membranes. So they're very important for us. Another type of lipid that we have is examples of chemical messengers. These would be steroids and hormones. Steroids, you've heard of like anabolic steroids. They are actually not just to build your muscles up, but steroids are also used to do different chemical functions in the body. And hormones are messengers as well. So if you need to send a signal from one place to another, that is done by a chemical messenger. Okay, those are the three functions of lipids. The basic structure of lipids, remember it's not technically a monomer because there are no polymers for lipids, but the basic structure is known as glycerol plus 3 fatty acids. The glycerol is on this side, so make sure that you write this down here. So the glycerol is this thing over here. And then the 3 fatty acids are over on this side. So we've got the 1, 2, 3 fatty acids. Now notice, these first 2 fatty acids are straight. I can draw my pen and just draw along them and it's a straight line. But if I look at this third fatty acid, notice what happens here. It bends. What causes that bend in the fatty acid? Well, actually it's going to be this right here. This carbon to carbon double bond causes the fatty acid to bend. We have special names for this. Some fats can be saturated while other fats can be unsaturated. Saturated fats are called this because they have the most number of hydrogens possible in this carbon chain. So there are all of the hydrogens possible in this carbon chain. That's why this is called saturated. Unsaturated fatty acids, on the other hand, they don't actually have all the hydrogens they possibly can because there's a double bond. And you can see on this diagram right here, there could have been a hydrogen here. There could have been a hydrogen here, but there's no hydrogens there because there's a double bond between the carbon. So that's called an unsaturated fatty acid. And again, unsaturated fatty acids are going to have a bend in their structure like this. And saturated fatty acids are going to be straight across. Now, this also causes a difference in the state of matter that each one of these fats are in. Saturated fats are going to be a solid at room temperature, and that's because these straight molecules of fats can actually pack really, really, really tightly in together. And you should know at this point that solids actually have molecules that are closer together than something like a liquid. So, because saturated fats are straight, and they can pack in really, really, really tightly. Saturated fats are solid at room temperature. Think about like a ream of paper. If you put a bunch of very flat pieces of paper on top of each other, it turns into like a solid. Looks like it would be a solid, and that's because those flat pieces of paper can stack together very nicely, just like a saturated fat. Unsaturated fats, on the other hand, because they have this little bend right here, that would be like taking 20 pieces of paper and crumpling them up and then laying them on top of each other. You can't expect that those 20 pieces of paper are going to lay totally flat and almost look like a solid. That's because they have bends in them because you bent them when you crumpled them. So unsaturated fatty acids are the same. Unsaturated fatty acids are not going to be packed quite as tightly. So unsaturated fatty acids are actually liquid at room temperature. So, an example of a saturated fat, one that's solid, would be like butter, and an unsaturated fat would be like olive oil. Saturated fats actually clog your arteries, so that's why people say not to cook with butter, but instead to cook with olive oil because it's a liquid and it's not going to clog your arteries. So, in your notes, it tells you to put a star by both of the saturated fatty acids, so please do so now. Okay, you should have put your stars right by the two straight chain saturated fatty acids. Now it tells you to put a triangle by the double bond. Do that now. Put a triangle by the double bond in the unsaturated fatty acid. Okay, you should have done something like that. So these are some checkpoint questions that you should try out on your own and see if you get them correct. So at this point in time, you should pause the video, and try to answer these questions. In a moment, I will restart the video. So pause it. Okay, the main functions of lipids are long-term energy storage. So your answer there should have been B. Carbs and lipids are both made up of CHO. And what is the major difference between the composition of carbs and lipids? It's the fact that lipids are made up of mostly carbon and hydrogen. So the answer to this would be C. The next question says, which of the following statements best describes the diagram shown below? Figure A shows a saturated fat and figure B shows an unsaturated fat. Figure A shows an unsaturated fat, figure B shows a saturated fat. Figure A shows both unsaturated and saturated, and figure B shows a carbohydrate because it's CHO. The answer to this one is actually going to be A. That will be the answer to this one. Figure A shows a saturated fatty acid because it's a straight chain. Unsaturated fatty acid has that double bond, which causes this to be bent. Okay, I think this is the final question, checkpoint question anyway. What is the basic structure of lipids? Pause for a second and try to answer this on your own. At this point, you should definitely know the answer to this. And the answer is D, glycerol plus 3 fatty acids.